All right, so let's start. First of all, with an announcement that I hope that you guys have seen my few announcements regarding final exam a day before yesterday. I put those announcements. So first of all, can I have a quick feedback from everyone? Have you guys seen my announcements regarding the final exam? A yes in the chat window, please. We have 5 to 6 people here, 5 people here. So can you write? Okay, Yash says yes, Seeking says yes. It's very important because I need to have that information that you guys know. Udit, you can also just say if you have seen, or if not seen, you can say no, no problem. You can just now go and look at those announcements if you have not already seen them. Okay, so so what I understood was that your group is comfortable having exam on Wednesday, August 14. Is that right? So again, after these yeses, after yes of Udit. So I think you guys have that slot available on Wednesday, August 14 for, okay, Yashu says yes. I would like to have others also just, please, please give your verdict. Atulya says yes. Wonderful. Wonderful. So, so what's going to happen is that actually, it's going to be your section, like section 9 and section 7 together on Wednesday, but section 8 is having a clash. So I will be shifting section 8 to their own day. That might be Tuesday. So again, yes. So your exam is going to be a final, final verdict or final announcement. It's going to be Wednesday, August 14, from 2 p.m. to 5 p.m. Like it's a 3-hour exam, and it would be in that slot. So I will just, make some final, the final announcements after those feedback, because I heard that section 8 is having a clash. So I'll just take them away from this part. But your section, like the section 7 and 9, they're going to have their exam on Wednesday, 2 to 5. Right. So, okay, I see Rukma, your yes. I see Adit, your yes. So please keep in mind, and of course, mark your calendars. And of course, I'll add the exam that will also maybe appearing on your calendar. So because it is a timed exam, and you have to just appear. So it starts at 2 p.m. and it ends at 5 p.m., around 3 hours, and it would be, so it's a recording for all the sections again, be it section 8 or 7 or 9. So it's going to be a more or less the same format that we had for our mid exam. It would be a combination of some objective type questions and then some subjective type questions and all those. And it would be basically, comprising of some of the questions that would test your generic understanding, and some questions that might test your specific understanding of the topics, because we have got different topics. So we'll just, so again, there will be some subjective questions that they are asking for something subjective, and there will be some objective topics that would be looking for some of the your basic concepts. So that is regarding the final exam. And again, everything starting from day one is included. And please keep in mind, it's a very important announcement, because every now, I see that some people, they will just go to some XYZ website and just copy the answer. I would be looking for an answer that was discussed during the class. And if you want to know that what was discussed during the class, either you had to be present in that class or you have looked at the recording. Because of course, as we are having this lecture with this section today, so 8 and 7, you guys are looking at recording right now. So actually, you need to just keep an eye on what has been discussed in class. So your answer, so again, a disclaimer here, your answer that might look perfect because it is coming from some so and so AI bot. So it looks perfect, but it would be considered as wrong. Rather, not that wrong, but rather it might be considered under the plague as well, plagiarism as well. So anyhow, so you have to keep in mind that your answers should be as generic as possible and as near to as this like discussion of the classroom. Like classroom discussion is very important. For that, I have always shared the recordings. You can find the recordings of each week when you go to your course shell. You see that whenever the lecture is not with your group, you see that I have shared the recording with you. Let me just show you that as well. if I can show you that. So when you go to the contents, for example, last week, it was a session with section 8. So of course, it was not with you. It's week 13. So when you go to week 13, you'll find that week 13, part 1, part 2 may be recording over here. And most of the times, sometimes, I have shared this over here. Like sometimes I have shared that recording in the announcements or the announcements made by there. So that is typically, you have to keep in mind that this is something that you have to keep in mind, that you have these things over there. So lecture recordings you will find over here. The code is also there. So everything is there, and you have to look at those recordings before coming to the exam. And again, just one more time, last point, last time, and then I'll just announce that your answer might be perfect again, as it is coming from some source. So you might get, not only you get a 0 for that, but for this time you will get a, this case would be referred of, and if there is something I find, I suspect that it has been copied from some AI bot, be it Chat GPT, be it your, your a WhatsApp assistant. So whatever, it's there. But again, if the answer is very perfect, but of course the answer is not according to what was discussed in class. So primarily you can just say that it looks odd, but for the exam, and just to keep ourselves in the race, that those people who have, of course, attended the lectures either, or of course those who have, for example, looked at all the recordings, they should be rewarded. So you might find that some answer is not looking that much perfect, but of course it is coming from our class discussion. It might be a student who has shared an answer, and I would like to have that answer from you. It might be a something that I have discussed during the section, during the, as if you remember in your quiz, you might find some questions. Quiz 2, I'm talking about quiz 2. You might have seen some questions that were directly in from the discussion that we were made in the classroom. So in general, what you have to keep in mind, starting from lecture 1 to lecture, whatever, this is week 14, from week 1 to week 14, everything that we have discussed in the slides or during our discussion, during our lecture discussion. You know that all the lectures are on YouTube. You can always go to YouTube and just find, in my on my channel, you can just find that with your course code PROG8081, and you will definitely find all those recordings if some week is missing from your box. Is that enough of the discussion of the exam? Again, everything is included. No question about what comes, what does not come. There might be a code, you need to write the output. There might be an output, you need to write the code, and vice versa. Whatever, you will have all those things to follow. So is it clear to everyone? Can I have now another last feedback before we start our today's topic, which is interesting one, NoSQL? So after Udit's yes, I would like to have everyone just put a yes or understood something, so that I understand that you guys have understood. Okay, Rukma, thank you. Srinu, Chinu, and okay. So again, if you are in a section that is looking at the recording right now, please keep in mind recordings are very important. And of course, there are some sessions that were happen with your class, and if you were there, of course, you should know them. And if you are not there in your class because of any reason, you can always find the recordings over there on YouTube, and you can always go there and find the recording, and you can play the recording and look at the lectures. Okay, so enough said about examination, and I wish you best of luck for your exam, for everything, and for your future things as well. Okay, Sarveshman, I don't see your user here. Oh, now you are here. Okay. So yes, so let's start our today's topic. So today's topic is NoSQL databases and big data. I just forgot to mention that. I'll just mention that over here because I've just added the big data as well. So it's our topic for today is NoSQL databases and big data. Rather, we will just discuss big data first, and then we'll go to. So big data from Wikipedia. It's the definition that has been taken from Wikipedia. I'll just make it correct. So big data and data warehouse. So now these are the buzz or the common words or common terminologies, technologies that we hear these days, and these are very like omnipresent technologies, omnipresent things that you will find. So what does it say? Big data refers to data sets that are too large or complex to be dealt with by traditional data processing application software. Um, it should not surprise you that the amount of data that is being produced these days is enormous, is really, is awful. Like, there are so much data being produced. Now, any idea, I would be happy to know this from you guys. Any idea when a plane takes off, maybe for, for half an hour, like it's a very short flight, it's a half an hour flight, maybe, and a plane takes, like, it just goes in the air, takes off, and is in the air maybe for 20 minutes, 30 minutes, and then it goes down, like again, descends, and it lands at another airport after 30 minutes, or maybe 30, 40, 40, 45 odd minutes. Can you guess how much amount of data that plane might have produced by that time? I'm just talking about one plane, by the way. You guys, can you guys guess something? A very rough guess? And we have got some of the resources to find out how many planes are like flying at one time. But I'm talking about just one plane that just took off for just 30 minutes, and it came back in within 30, 35 minutes, odd minute. How much data that would have produced? Any idea? Anyone? Okay, Tinu, yeah, Tinu, yes, that's a very good answer. No idea, but there has to be an answer. If there is not an answer, it should be no idea is an answer, and no answer is a bad answer, by the way. So yes, Tino, no problem, no idea. Anyone else? Okay, Neil, that's a good answer. Again, thank you for answering at least. It means that you're listening to me. Minimum. Okay. Anyone else? What do you think? So again, this is something which is not in slides, of course, and I'm just, I'll just, give that. Let's do a little bit Googling about that. How much data is produced by a plane of 30 minutes duration? Let's see that roughly. If Look at that. I was just about to say terabytes of data. Look at that. If I just show you terabytes of data generated by Boeing jet every hour. Now listen, every hour it produces terabytes of data. Tino, do you see that? It's really, and I think I read this article, and that's why I was just asking this question. That article from GigaOM, etc., says that sensor networks, top social networks for the big data, says that twin engine Boeing jet aircraft generates a lot of information, 40 terabytes per hour. Isn't that huge? Like, 40 TBs per hour. So we can imagine, and you might have seen this website. Of course, most of the people know about this website. I'm just talking about right now, just talking about the plane which is producing the data. Have you guys seen this website, flightaware.com? Flightaware. And yeah, if I just show you over here, let's see. You see, Neil, do you see that? These are all the planes which are flying right now. You can see that, like, and it's just this region that it is showing, the region that we are in, maybe, some diameter of our region, and it's showing that how many planes are right now on their way from one place to other. These are all the planes flying, and you can imagine when it says our first article, what it says, that actually, jet aircraft like Boeing engine, like a twin engine Boeing jet aircraft is producing 40 terabytes of data. So can you imagine how much terabytes of data is in this picture? Do you know any idea? You can safely say that, maybe millions of terabytes is, yeah, humongous, you're right. And it's, millions and millions of terabytes of data. Yes, you're right, humongous data. So that's really, something. So this, and again, we are just talking about one of the aspect, the airlines. We are not talking about the patients being treated at different hospitals at all the time. We are not talking about, we are not talking about so and so fields. Yeah, you name it. Like Olympics going on, the how much data that Olympic is producing. You know how much data that one match is producing, because they're just capturing each and every move of the players, and then medals are updated and so forth. So you can imagine that how we which world we are living in right now. Do you see that? And really, whenever I see this website flightaware.com, I really get amazed looking at that one. The amount of data that is basically being used here. So I'm giving a very rough estimate. I don't know. It's just a rough estimate that I'm giving for maybe exam purposes. So I would say that, okay, right now what I see is that, for example, 500 planes, in this particular area. Who knows? I don't know. I'm just giving a very rough calculation. you know so 500 planes producing 40 terabytes of data each hour. Imagine what's going on. So this is, these are just, as I said, these are few of the examples or few of the areas which are producing the data. And this article might have shown much more things that would really surprise us. And that is the thing. So anyhow, so big data. Let's talk about big data. I was talking about big data. So big data refers to data sets that are too large or complex to be dealt with traditional data processing. Your poor Microsoft Access database. Forget about the big data. Forget about the data of the airlines. Forget about a big organization of giant like Facebook or Google or Amazon. Uh, this Microsoft Access, with a very with its own limitations, with its own things that it has, it will just fail on a maybe medium-sized enterprise when there is the data is going above its head. So forget about Google, forget about Facebook, forget about Amazon. It will just fail about for a particular reason. It will just fail. So this is one thing that I was just wondering, and I just wanted to talk about that. These normal data processing applications, traditional, they're saying traditional, and it also includes our good friend as SQL as well. SQL is so far powerful, but of course the data, when it goes really in a mad humongous number, what happens is that you are not really able to handle this data. So now, in computing, a data warehouse, DW or DWH, also known as Enterprise Data Warehouse or EDW, is a system used for reporting and data analysis, is considered a core component of business intelligence. So that's interesting thing. Is a system, that data warehouse is a system or something that is used for reporting and analysis of data, because the very important thing is that analysis or analyzing the data that is there. So analysis, and it's a core component of business intelligence. It's basically, it really is a core component of business intelligence that it shows. Okay, so business intelligence systems, sales, HR, finance, producing a lot of data. ETL, what is that ETL? We'll just talk about that. So data warehouse will be handling that one. So these transactions, enterprise transaction will be coming up over here. Data warehouse will be have capturing that, managing that, keeping that data with it, and then the analysis and reporting is basically done by having that data warehouse, and that's quite an interesting fact, right? So data warehouse or DW concepts. Data warehouse does what? It store data over a longer period of time, very longer period of time. We are talking about aggregate and format data for analysis and reporting. Of course, that is one of the primary job. That is one of the primary responsibility of a data warehouse, that it should it should be able to capable of of aggregating the format of the data and report for the analysis and reporting. Because whenever you want to just analyze your data, you need to have that in a form that is acceptable by for analysis, for reporting. Sometimes the data is so much scattered, so much unclean, so much bad that you're not able to make analysis on that data. You are unable to make the reports on that data. So that's why that uncleaned data, I'm calling it unclean data. So you might call it anything. So that becomes important. So data warehouse has this responsibility of aggregating that and formatting that data so that it could be analyzed, it could be reported in a good fashion, in a humanly fashion. Use the same relational structures as other databases. It uses same relational structures. By the way, I don't know, it's still data, even though we have gone into DW data warehouse, but still it uses the relational structure, and that's quite interesting. Relational structures are populated solely through extract, transform, and load, ETL. That was we're talking about, extract, transform, and load. So they would be used by ETL, extract, transfer, and load, and they would be just use that. So ETL process occur on a regular schedule. So there would be schedule that would be following along for ETL. Benefits: relieves resource pressure from operational databases. Keeps data to itself, and whenever operational database needs something, you just get it and you just perform something you want to perform, and just return it back to the data warehouse, which will just keep that one. So it relieves a lot of pressure, because if you have a database processing application going on and you just bombard it with a lot of humongous data, so what happens is that the data would be, the application might goes down and go down, and there are lots of there are lots of there were lots of organizations that really felt this one. There was a humongous data, and they just they just failed down. Their systems just got failed down. Single point of contact for all analysis and reporting. Okay, you have got one point where you just whenever you want to analyze some HR things, you have one point. You have whenever you want to create a report for HR, you have one point. Whenever you want to have analyze sales, anything, that you have this this box in between, the data warehouse in between, that will take care of those things, right? Allows tuning for query analysis and requirements. Of course, you can tune tune out your queries for analysis and requirement. Maintain historical records. As we are saying that it's a longer period of time, so the benefit is that it maintains historical records, and historical records are very, very important. There are lots of information that would be presented in form of historical records. Okay, so online transaction processing. So one of the typical operational databases are OLTP, online transaction processing. Typical operational databases. What are that? Efficiently and modify records or perform transactions, follows a normalized relational data. These are they're talking on OLTP, that is generic. That is, we have generic operational or typical operational databases that just does what? They will just do what? They will be having their generic description, generic things being going on, and they would be just having all those generic things, so to speak. So they're saying that, okay, the first thing is that the online transaction processing systems, they would have this facility that they would be used in that typical manner, and you can use them. You can just have their reports and everything. So now if you talk about OL, then we have OLAP, online analytical processing. That's interesting. Database created to facilitate efficient analysis. Okay, this will be there to facilitate the analysis. Data warehouses are OLAP databases. Of course, data warehouses have this analytical processing feature, and they would be having these OLAP databases. Need to accommodate for far fewer transactions. So their transactions will be very, very less, and we need to just accommodate those transactions over here, and nothing else could be could be adjusted, and that's the thing that would be there. So data warehouses are there, need to accommodate fewer transactions. Data is loaded in scheduled batches, typically overnight. So overnight, this data will come, some processing will happen, and then just goes away. That typically. Data is denormalized and restructured. Of course, whenever you have to go back. So reversal will be done. So here is the difference between these two. OLTP, transaction processing, OLAP, analytical processing. Prioritize writing and modifying data quickly, securely, and consistently. Prioritize performing queries and answering questions quickly. OLAP is something, our point of contact when we are talking about typically the data warehousing, right? So it is typically there. Now, yes, so this is we have just theoretical understanding of that one, and as I said in the beginning, we'll have this will be a very quick tour of these things. We might not have any implementation of that one. So then NoSQL. Now, the term NoSQL covers a wide range of technologies, data architectures, and priorities. It represents as much as a movement or school of thought as it does any technology. NoSQL. When we hear this NoSQL word, some people say that it's a NoSQL. But look at the second point. Even the name is confusing. For some, it means literally any data storage that does not use SQL. But thus far, the industry seems to have settled on not only SQL. So remember, it looks like that it is NoSQL, literally no sequence, and that's why it's confusing. The name is confusing. But what is that? It's a wide range of technologies and data architectures and priorities. It represents a much of movement of school of thought as it does any technology. So it's a school of thought. It's not just like it's just like a more than a traditional like metaphor that just represents any of the databases, and it does not basically represents any typical typical thing. And that's something that it just handles one. So as time goes on, it is likely that scope of term is going to grow and grow until it becomes meaningless by itself, and subdivisions will be needed to clarify the meaning of the term. Right. So it's you see that as a quantity, it's likely that scope of the term is going to grow and grow until it becomes meaningless by itself. Sometimes it might after 50 years the term the term NoSQL becomes not very prominent or not useful. So that is about that. People will say, okay, forget about the term, but we are talking about, because the technology has moved so faster that now we have got a lot of things that might not be there for a particular thing. So right. So that's for the NoSQL. Relational DB versus NoSQL DB. So what are those? So relational DB is basically reliable, consistent, and strong integrity. It's relational database. NoSQL is basically flexible and scalable and fast. So relational has its own importance, and NoSQL has its own importance. But of course, when we make a comparison, we can just have a look at that. Which one you need that? If you have, of course, a little amount of data, you might never want to just go for that particular that thing that you have, typically that you don't want to have that thing. So, but if you talk about in a generic sense, in a very generic sense, if you talk about that, you will say that it's if you need a big amount of data, there are humongous data, and you want to have that a flexible thing, so you will just go for the NoSQL databases for sure. So NoSQL, again, if we are just continuing from that definition, just after that, NoSQL movement is a piece of guerrilla marketing that brings together a broad group of technologies under one banner. The idea that underpin the myriad solution that exists under the term NoSQL have previously only been available to those whose unique needs meant they had to develop and build them. So they had to develop something and build them, because NoSQL just came the technology, and it says that it comes as an umbrella that has a lots of technology inside that one, and now people will not have to make their own databases for their own needs. Rather, what they will be doing is that they will be just using the one of the umbrella technologies, and that will solve their problem. It also seems likely that most solutions will consist of a hybrid mix of storage solutions. Most of mixes of n-tier and client-server architectures tend to be more common than absolute commitments to one strategy. So again, the most solutions will be hybrid mix of storage solutions, and that would be n-tier or client-server architecture. So any type of n-tier server application, it would be it would be, rather workable and usable in those situations. So the main feature, NoSQL is large and expanding field, but at this time, the common features of NoSQL data stores are. So it's basically, they are just there. This is just a disclaimer here that might be, in very near future, you will find that these main features have either phased out, or these main features have either increased in a big number. So that, there's a disclaimer that at this time, what are the features? If you look at that, easy to use in conventional load balance clusters. And this is a terminology, load balance cluster. If you guys know about any of the cloud technologies, does anyone of you know any cloud technologies, likes of Azure, the GCP, likes of Amazon Web Services? Has anyone idea of that one? Okay, Tinu, thank you. Not used yet. And Zulia says no. Okay, right. So when you say that we have clusters that we create in our the cloud environment, or in those databases, distributed databases, we make clusters of load balancing servers that would be taking care in case when there is a calamity, natural calamity, or there is a crash in your databases. So there are load balance cluster, or there too much load on a particular branch. So we will have so NoSQL is basically suitable for those situations where you have to make a clustering of your load balancing servers, because one server getting too much requests will bog down, will not be able to just work with that one, and the load balance clusters will be basically taking their reason. So persistent data, not just caches. So it would be a persistent data, of course, NoSQL, scale to available memory, and it will just whatever memory is available, it will just vertically scale up. So not to scale down, it will vertically scale down. So vertical is basically a vertical scaling. You might know. Do you guys know what is vertical scaling? And so I'll just leave that on you. Vertical scaling and horizontal scaling. You just have to find out. If you don't know, find out that one. It's something that I'm just giving you for the reading purpose, and that might be in exam as well. So persistent data, not just so scale to available memory, have no fixed schemas and allow schema migration without downtime. So schema might migrate without disturbing the downtime. How many of you have focused, or faced that problem, that sometimes your email was logged in, but suddenly you see that it just again is asking for your password and ID and your requirement. Has anyone focused that one? Suddenly your account is again asking for your password. Sometimes it happens. Has anyone faced that one? Any one of you? What is that happening? That is actually, yeah. So Atulya, yes. And that's, what happens is that sometimes the server you are attached to has been shifted to other, because there might be. So Rukma, you were basically connected to a server in South Asia, for example, and that server was holding you and a lot of users, but then users were so much stressed on that one, and there were some users, they had the priority level higher than yours. So what they do is that seamlessly they would transfer you from their own server to another distributed server. And what happens is that when you are transferred to distributed server, to make sure like the security, privacy, and everything, the next server will just ask you, okay, just can you enter one more time the password, because you feel that, okay, something as bad has happened and my email account or my account has gone out of that one. But that's not the case. Actually what happens is that you have been switched from one server to other. So seamlessly that happens. And in the database, we talk about the schemas, the schemas we talk about. So schemas, they are also a schema migration happen without the downtime. You will never be downtimed. You will never be taken away from the database, and the schema will be changed. And that's quite interesting. And because data schema is something that is really important in databases. So have individual query systems rather than using a standard query language. They have an individual query system. Don't worry about SQL. Don't worry about learning SQL in a very proper format or a general format. Rather, you will be able to just learn language or the query system of that particular system that has been implemented. Are near ACID within a node of the cluster and eventually consistent across the cluster. Near ACID, they are not ACID. Anyone remembers ACID? Can someone tell me what is the ACID? Maybe acronym for this ACID? It says that it's a near acid, not of course the acid, the exact acid. What was acid? Anyone remember acid? Yeah, exactly. Atomicity and concurrency. Yes, you're right. And Srinu, that's something that you would really like to review again for your final exam as well, because it might be, yes, durability, atomicity, concurrency. So that's typically these are there. And one of the lecture we have discussed these acid transaction. Right. So now let's come back here and see the. So there's a CAP theorem. What is CAP theorem? Consistency, availability, partition tolerance, working as expected, even part of the system is down. So this is CAP. So now what is this CAP thing? That consistency should be there, availability should be there, and partition tolerance. Like again, if one of the partition is down, like the system is down, partly the system is down, the other part will just take care of that one. So that is being shown over here. RDBMS, they have consistency and availability and partition tolerance. So we are talking about these three things. So now if you look at that over here, that MongoDB, HBase, and Redis, it has C and P, right? Consistency and partition tolerance. Neo4j is a database which has consistency and availability. CouchDB, Cassandra, DynamoDB, it has availability and partition. So you see that this is a very, very important diagram. I would like you to just have a look at that diagram. And remember, MongoDB is one of the that we want to discuss, that we'll discuss a little today. And then we have database like RDBMSs, general RDBMSs. They have the consistency throughout that one. Then Neo4j is one of the database that has consistency and availability. So this is a very important diagram with respect to the the exam as well. You have to keep in mind and look at that one as well. Keep that in mind. So NoSQL in AP, high availability, imperfect but eventual consistency. So in AP, if you just look at that one, this AP, like Cassandra DB, DynamoDB. So what it does is high availability. It's high availability. It's imperfect but eventually consistent. So it's not perfect. Like that's why it's imperfect, because it does not have a consistency, but it would just give you a lot of that. So NoSQL CP, partition tolerant. So if you see CP, so it's consistent with replication. It's consistent with replication or the partition tolerance. For example, MongoDB. So remember, MongoDB is a CP. From this CAP, MongoDB is CP, and there are lots of other databases that have been mentioned. So this diagram is important for you, for your purpose. Now, types of these NoSQL databases. And I'm not giving a break today because we started late, and this is a short lecture. We have just 32 slides, and we'll be just ending with that one, right? So types. So we have key value stores, we have document databases, we have graph databases, we have XML databases, we have distributed peer stores. These are all the types of NoSQL databases. Now, key value, the first one, key value stores. Example, Tokyo Cabinet / Tyrant, Redis, Voldemort, Oracle, BDB. These are all like, key value NoSQL databases. The typical applications are content caching. Like, we'll just talk about the content caching. And what are the strengths of this one? It has fast lookup, high velocity data, and weakness is stored data has no schema, data volume limitation. So again, weakness, just remember the weakness. And, just remember that this Tokyo Cabinet / Tyrant or Redis or Voldemort and Oracle BDB, they all come under key value mapping, key value databases, NoSQL databases, and they have this weakness, stored data has no schema. Right. So that is another very, very important aspect that you would like to just remember, that it does not give that one. So it has a weakness, and that weakness is that it has no schema. Right. So next one, key value example. You're writing from forum software where you have a home profile page that gives the user statistics, messages posted, etc., and the last 10 messages by them. The page reads from a key that is based on the user's ID and retrieves a string of JSON that represents all the relevant information. A background process recalculates the information every 15 minutes and writes to the store independently. Remember this diagram, this example. This is very interesting. You're writing a forum software where you have a home profile page that gives users statistics, how many messages someone has posted, right? So for example, Alex has posted 300 messages. I'll just give him a rough thing. Alex has posted 300 messages. So these messages, how it will find out that Alex will have an ID. So it will just go to the user ID of that, Alex's ID, and it will just try to retrieve all that data that would be in JSON format. And we know that JSON format is basically a format where there are double quotations around the field and everything. We have talked about that one. So a background process recalculates the information every 15 minutes and writes to the stored independently. So, a background process is running in behind that is just going over there and, recalculating the process information and just returning, because user might be posting every now and then user will be posting a lot of information. And if the user are posting a lot of information, your background process is basically responsible that it is going behind and is just trying to find out those things that has changed. Document-based databases. This is very important. Document-based are examples are CouchDB and MongoDB. Typical applications, web applications, very important. It's very important for web applications, and we use MongoDB or CouchDB as a NoSQL database in our that web applications. Just to speak, we have to without. Strengths: tolerant of incomplete data, schemaless. It's tolerant of incomplete data. Like if the data is incomplete, there are certain records which are missing some particular fields. Like, for example, if I give you an example, which might not be that appropriate in today's situations, but I'm just telling you that, for example, if there is a data that is coming and every student, it's a student data and every student has an email address, but one student does not have an email address. So if that does not have an email address, what will happen? That the area which it will be using, that would be empty, but document will just accept that one because it does not. It is intolerant and it's schemaless. There is no typical structure that has to be followed. There is no typical a requirement that has to be followed when the data is basically being coming into that one. So that is basically, what we say is that the strength of that particular database. Weaknesses: query performance, no standard query syntax. Well, so that is a weakness of the document one, because query performance is not that perfect, because queries take a lot of amount of time. You remember when we used to do in SSMS, there were a few queries that used to take a lot of time, and sometimes it was just hanging up, or it was just not just giving that those particular things. And if you have looked at the this last 2 weeks, like this is 14, 13 and 12, like the lectures, like the recordings from week 8 and with section 8 and section 7, you would have seen that we have talked about a lot of security issues. And before that, when we were running the queries got used to stop, and we were just looking at the query that it will run, but there were lots of stoppages for those queries, and because of those stoppages, we were unable to run those queries, right? Okay. Document example. You're creating a software that creates profile of refugee children with the aim of reuniting them with their families. The details you need to record for each child vary tremendously with the circumstances of the event, and they are built up piecemeal. For example, a young child may know their first name, and you can take the picture of them, but they may not know their parents' first names. And that's an irony, because if you're collecting the information for this refugee for type of things, and there are lots of kids that of course they do not know their name of their parents because of the calamity, because of the problems that they have faced. So you will not be able to have a consistent data, because some people you will have the first name and last name, some people you might not have that one. And that was I was talking about, that in those situations, in those data situations where you see that, like, the data is not getting complete, like all the fields are not important, or we are not able to fill all the fields for all the particular like participants. then you would say that this data isn't like the database that will suit this situation is basically, is basically the document type of database. So again, one of the example they've given the refugee data. One example I gave you that a student does not have an email address. So remember that these are the two examples that you would keep in mind. Later, a local may claim to recognize the child and provide with you additional information that we definitely want to record. But until you can verify the information, you have to treat it skeptically. So again, later on, someone turns up and it says that, turns on and it says that like there's information of that particular child, and you have to just adjust that information as well. And again, you will verify that information from some of the resources. And after finding those information is correct or not, you will be just trying to you're just keeping that as skeptical information, and that's very important. This is a graph databases, and we have seen Neo4j is one of the graph database. Infogrid and Infinite Graph, these are all graph databases. Typical application, social networking. One of the very popular is Neo4j for social networking when you are doing social network analysis. If you have heard about social network analysis, it's basically finding out some key areas from key people who are the influencers and things like that. So for making these recommendations for doing this social network analysis, we might want to use Neo4j database, which is very important. Infogrid, Infinite Graph, I've not used. I've seen info in like Neo4j. Strengths are graph algorithms, for example, shortest path, connectedness, and degree relationship, etc. So strength are like by using these Neo4j on those databases, what we can do is that we can find out, we can use the shortest path algorithms, and we can use connectedness between the different points, and that's a very important use. Weaknesses has to just traverse the entire graph to achieve a definite answer, not easy to cluster. So again, as I said, the social network analysis might be, we are finding the influencer. So if we are finding the influencer, we might have to just make a lot of traveling from one part to the other to just find out who is the influencer out of these particular people, and that at times is a real challenge. And so we have to traverse the entire graph to find out something, because there is no sequencing, there is no keying over there, there is no specifically pointers that would point you to the data. All right, graph example. Any application that requires social networking is best suited for graph database. These same principles can be extended to any application where you need to understand what people are doing, buying, enjoying, so that you can recommend further things that them to buy or like. Anytime you need to answer the question along the lines of what restaurants do the sisters of people who are over 40 enjoy skiing and have visited Kenya, it's like a graph database will usually happen. These days with the advent of these AI chatbots that we are talking about, that you might not want to use in your exam, as it's a danger of having a real reprimanding, you might be reprimanded for that. But anyhow, so that's actually that's graph example is always good in those situations where you try to find out those. XML, another one which was a very popular one before JSON really took it over. So example is Exist, Oracle, and MarkLogic. Typical applications, publishing, all those publishing sites, all those publishing applications that want to do the publishing job. XML will play a very important role. Like not only XML, but also Oracle, or we have MarkLogic, that they will just play a very, very important role. I would like you to just scroll, or just try to find out this MarkLogic as well in a bit of detail. Read about that, find out what is MarkLogic. We have Oracle, we know about the Oracle. Strengths, mature search technologies, schema validations. They have a mature technologies of searching, and we can very easily search that one. And schema validation is there. But the problem is that no real binary solution. Easier to rewrite documents than update them. So that's a problem that you might some with malicious intent. Someone was stub, and it would just change the data. It will just take away the original data, and it will just overwrite the data. That will really cause a real calamity for your information. XML example, a publishing unit that uses bespoke XML formats to produce web, print, and ebook versions of their articles. Editor needs to quickly search either text or semantic sections of the markup. That is article whose summary contains diabetes, where the author's institution is Liverpool University and Stephen was revising editor. At some point in the document history, they store the XML of finished article in the XML database and wrap it in a readable URL web service for the document production systems. The workflow metadata, which stage of a manuscript is in, is held in a separate RDBMS when the system-wide changes are required. Xquery updates, bulk updates all the documents to match the new format. Xquery is another very important thing. You have to look into that one. What is XQL? So these are few, few self readings, and I'll just mark them over here. Some self readings. Double star. I'm just making that one double star over here, and I just give you one more thing. What was the other thing that I said that you might would like to read? That anyone remembers? What was the other thing? The smart logic, right? So I'll just write it over here. So that we can. So I'll just put that here as well, because here also we have a star. I'll mark it red color so that you recognize that one. Right, so just do some research on these topics. Distributed peer. There is another type of databases. So examples are Cassandra and HBase React. And typical applications, distributed file systems, strengths, fast lookups, good distributed storage of data, and very low level API. So weakness is very low level API. API does not give you quickly access to the required data. It's very low level. It means that it just goes in the depth and it brings out that data, but it does not actually give that particular information of that one. So weakness is very low API, but they are this distributed system. And Cassandra is one of the very popular one, with along with HBase as well. That they are basically they are one of the very popular distributed database systems, and they will be they have this feature, fast lookups and good distribution or storage of data, and that is a main thing or main takeaway for that one, that you have got. But its problem is that weakness is very low level API. Example, distributed peer. You have a news site where any piece of content, article, comment, author profile can be voted on, and optional comments applied on the vote. You create one store per user and one store per piece of content using a UUID as the key, generated one for each piece of content and user. The users store. This should be the users store, I think. Yes. User store hold every vote they have ever made, while the content bucket contains copy of every vote that has been made on the piece of content. Overnight, you run a batch job to identify content that users have voted on. You generate a list of content, and what you do is that for each user that has high votes but which they have not voted on, you then push this list of recommended articles to the users bucket. So that's a very interesting example of distributed database. So this is the last topic, MongoDB. MongoDB is another very interesting NoSQL database, and we would like to just discuss about it, because MongoDB is very humongous and it is used in most of the applications. So what we'll do is that we'll try to just find out what it typically will do. So MongoDB is an agile and scalable NoSQL database. Agile and scalable. That's very important. Do you guys know the concept of agile, by the way? Agile. You might have heard this term in the software engineering somewhere, or software code development and software courses. Yes. So what is that? What does that mean, Shrino? Do you know any idea of agile? What's agile technology or agile thing? Because I would be happy to know that if someone can answer. Incremental kind of. Okay. Anyone else? because Shinu is always replying. Shinu and Tino are already replying, or maybe sometimes Athulia, but most of you are not replying. Anyone else? Incremental kind. If you guys know what is agile, can you just let me know what is agile technology? Okay, what is agile? You are very right, incremental. And when we say scalable, again, of course, since it is agile and incremental, it will be scalable. So NoSQL database. So MongoDB has these features, and that's why usually MongoDB is one of the choice of that one. And one more thing, if I just write it here and I'll remove it here from here, I you might know that there are two full stack suites. One of them is called mean and one of them is called MERN. I'll remove this from here, but just for understanding, I'm just telling you. Have you guys heard about this mean and MERN? Children, have you heard this mean and MERN? These two? Okay, Tino has heard. Tino, can you tell me what is this mean and MERN? Or maybe if I have discussed that before. Angular and React, right? And what is this M in that? What is this M? M is Mongo. And what is E? And what is E, Rukma? Express, Tino. Yes, wonderful. And what is N, by the way? Just last. What is N? It's Node, and not only Node.js, which is the platform which is a runtime that actually like keeps that one. So that is this Node, this MongoDB is. I'm just trying to tell you the importance or the standing of MongoDB in different technologies or different like its integration in different technologies, that you would see that it basically fits into both types of the stacks, it be it mean stack, be it merge stack. And this merge stack um, is basically there. So that typically is, these are typically two stuff. So Mongo is very important. As I said, this will just, they will become one of the part of that one. The name Mongo comes from the word humongous, as someone used this word today. MongoDB is based on NoSQL document store model, remember, document, in which data objects are stored as separate documents inside a collection instead of traditional columns and rows of a traditional relational database. So you have to remember about this, about the MongoDB, that it's a document store model, and it basically does what? It keeps the objects as separate documents, and it's basically just keep them, and it will be just taking them out or extracting them out when needed. Documents are stored as binary JSON and BSON object. It's called JSON, like JavaScript object notation, and this got BSON. I think it's binary state object notation. So then these are the objects that will be saved. The motivation or B, I'll have to find out what was this B. If someone knows, they can tell me. I just forgot what was this B. I think it's binary or something else. There was a technology, term used for this BSON. Okay, the motivation of the MongoDB language is to implement a data store that provides high performance, high availability, and automatic scaling. So it is basically, MongoDB language through MongoDB. What we want is that high performance, high availability, and automatic scaling systems. We try to find out. If someone can find that out, they are just making a service to the to them. So now the MongoDB is extremely simple to install and implement. MongoDB offers great website backend support, high traffic website that need to store data such as user comments, blogs, and other items, because it is fast, easy, and implement. So again, people will be remember these examples that are saying from the website that are using comments and blogs and other items. They would be preferring MongoDB rather than any other thing. So MongoDB, what are the features? Document oriented. Because MongoDB is document oriented, the data will be stored in database in a format that is very close to what we will deal in both server side and client side script. This eliminates the need to transfer data from rows to objects and tag. That's very important. It's document oriented. It's high performance, is one of the highest performing databases available. That's why in real world, in current world, we have got these two, these suites that are just having this M as the first word, or rather, this is the first word. In a full stack application, you will need a MongoDB database, and you will just use that. High availability, MongoDB's application model makes it easy to maintain scalable while keeping high performance and scalability. High scalability, of course, its structure makes it easy to scale horizontally by sharding. This sharding is another thing that I'm not telling you. Again, might not be a directly part of it, but again, I would like you to just, have a look at that sharding. What is sharding and what is shard? There is one thing called shard. What is sharding? You have to just get and like find that out, and that is your responsibility that you will be just doing that one, right? Okay, so this is a like a MongoDB, like MongoDB's data, that there is a field and then there is a field value in, again, in object form. It might have an array, it might have lots of other things, as you have maybe seen that before. So these are collection. This is called a collection for storage of groups of documents. So this is one document. If you look at that, this is one document. And these are like collection of documents, and this is called collection. So you look at that, MongoDB uses the word collection for storage and group of documents. Just give me a second. Am I missing something? Oh yeah, we are missing something over here. If I make it black, yes. So MongoDB, this is basically one of that example. The collection is basically when you have multiple documents combined together. It's called one collection. In MongoDB, a query targets a specific collection of documents. Queries specify the criteria or conditions that identify the document, and that MongoDB returns. A query may include a projection that it specifies or that is matching documents you can return. So, we ask DB users find, and we just give that, and it will just go there. And it's very interesting, if you just look at the theoretical aspect of it, that's very interesting. And we just, we can say DB users find. We go to the users collection and find if age is greater than 18, and then sort that. These are called modifier. This is called query criteria, and we'll just return those values. So look at that. In the same way, DB used to insert. If you want to insert something, it will go and insert in the document. And since it is document object model, you know that it won't have that much issues of the structure or anything. So MongoDB operational intelligence, storing log data, pre-aggregated reports, hierarchical aggregation. Product data management, product catalog, inventory management, catalog hierarchy, and content management systems, metadata and asset management, storing comments. That's basically one of the feature. So at this point, you should be able to what is NoSQL acronym stand for? What are some common types of NoSQL databases? What types of NoSQL database is MongoDB? And this very much sums it up again. We are not looking into a practical example, even though you can just download this and we can just run that one, because NoSQL has some interesting management tools that you would like to just install that one. And there are some interesting tools, but again, it's not something that we are basically covering over here. So that very much sums up our today's lecture. As I said, it would be a short lecture. It won't be a long lecture. And I would now just update this for your week 14. Sorry, it's week 15. So yes, they had an admin file that I don't want to use. We have discussed that in the security. So I would just come here and I'll upload this file. Okay. And let's do that. I've uploaded that over here for everyone. I'll just upload that for all the. So now we will have final exam next week. And as I said, for your group, it's going to be on like Wednesday, August 14. Please keep in mind, section 9 and section 7, they are going to have your exam on Wednesday, August 14, and section 8 is going to have on a different day. So keep your eyes on that one. And again, exam might be in the same format as it happened before. I might not be available because I always say that the understanding the question is part of the exam. You understand that, make reasonable assumptions. If you make reasonable assumptions, I would definitely, and you can just prove that later on. I would be able to just accept that one, right? So thank you very much everyone for joining in. If you have any questions, you can just go ahead. I would be happy to answer your questions if you have any. And if you don't have any questions, you can just write no question and leave and get yourself ready for the exam. And we would like to just, meet for exam then. Any questions from anyone? Okay, thank you very much, Srinu. Thank you, Rukma. And yes, I would like everyone to just put a chat message, a last parting message, so that we will be just talking about. Okay, Neil, thank you very much. Enjoy your day and best of luck for your future.